A 5-stage pipeline has stage delays of 150, 120, 150, 160 and 140 nanoseconds. The registers that are used between the pipeline stages have a delay of 5 nanoseconds each. The total time to execute 100 independent instructions on this pipeline, assuming that there are no pipeline stalls, is how many nanoseconds? So we know that if we are given the latencies for each stage, then in a pipeline we take the maximum of this, and this will give us 160 nanoseconds. This will be the clock cycle time, and this much time is required for each stage to complete its task. Also, it's given that there are interstage registers and the delay of one interstage register is 5 nanoseconds. So if we compute the effective clock cycle time, it would become 160 plus 5, which is 165 nanoseconds. So the first instruction will require 5 clock cycles. So 5 clock cycles for the first instruction multiplied by the clock cycle time gives us 825 nanoseconds. Now out of these 100 instructions, now we are left with 99 instructions and they will require 99 clock cycles. So 99 clock cycles multiplied by the cycle time is 16335. So adding the time for the first instruction and the remaining 99 instructions, we get 17160 nanoseconds. So the second example is that the instruction pipeline of a RISC processor has the following stages: instruction fetch, instruction decode, operand fetch, the perform operation and the write back. Instruction fetch, decode, operand fetch and write back, they take 1 clock cycle each for every instruction. Consider a sequence of 100 instructions. In the perform operation stage, 40 instructions take 3 clock cycles each, 35 instructions take 2 clock cycles each, and remaining 25 instructions take 1 clock cycle each. Assume that there are no data hazards and no control hazards. So the number of clock cycles required for completion of execution of sequence of instructions is how much? So we know that there are 5 stages in this pipeline, and assume that each stage was taking only 1 clock cycle. Then in a regular pipeline, how many cycles would be required? The first instruction would take 5 clock cycles and the remaining 99 would be completed in 99 additional clock cycles. So the total clock cycles would be required would be 104. Now let us compute what are the extra clock cycles that this pipeline is taking. It's only in this 4th stage, the perform operation stage, that there are 40 instructions which are taking 3 clock cycles. Regularly, they would take 1 clock cycle, but they are taking 2 clock cycles extra. So 40 of these instructions are taking 3 minus 1, which is 2 clock cycles extra. 35 instructions, they should have normally taken 1 clock cycle, but they are taking 2 clock cycles. So 2 minus 1 is 1, they are taking 1 clock cycle extra. And 25 instructions, they are taking 1 clock cycle, which is expected. These 25 instructions are not taking any extra clock cycle. So these only are the extra clock cycles that are being taken. And if you compute this, we get 115 clock cycles. So 104 plus 115 gives you 219. So these are the number of clock cycles required for the completion of execution.